are the SSTU biologists and we are about to tackle fluoroscopy. What is fluoroscopy? Well, it is the study of moving body structures similar to an X-ray movie. A continuous X-ray beam is passed through the body parts being examined. The beam is transmitted to a TV-like monitor so that the body part and its motion can be seen in detail. History of fluoroscopy. The beginning of fluoroscopy was on November 8, 1895, when a German physicist named Wilhelm Röntgen noticed a platinum cyanide screen flourishing as an X-rays. Early fluoroscopy. This image shows the early fluoroscopic machine built in the earliest time. The first fluoroscopes were created after several months of this discovery. Early fluoroscopes were cardboard funnels with an open at the narrow end for the observer's eyes, while the wide end was closed with a thin cardboard piece that had been covered on the inside layer fluorescent metal salt.
This procedure had to be done in a dark room due to limited light produced from the fluorescent screens. As a result, there were radiation doses to the radiologist looking through the screen. To prevent this, great adaptation goggles were developed by Wilhelm Röntgen in 1919, so that the radiologist can function normally during the procedure.
The image shows how the radiologist examined the body of his patients during the earliest time of fluoroscopy.
What is fluoroscopy? Fluoroscopy is the study of moving body structures. It's similar to an X-ray. Fluoroscopy is also an imaging tool. Allows physicians to look at various body systems such as skeletal, digestive, urinary, respiratory, and reproductive system. And it shows continuous X-ray image, plays out like a movie. Image taken quickly allow for this to happen. Shows movement of body parts. Also shows instrument or die.
Moment, we talk about the fluoroscopy machine. Takes a continuing stream of X-ray image, approximately 25 to 30 images per second. Image are viewed on a monitor, sort of like a television screen.
Fluoroscopy image. First, amount of radiation needed varies based on procedure. The second important characteristic of fluoroscopy, sensitivity, is amount of exposure needed to create an image. Third, non-intensified fluoroscopy. Use a fluorescence screen only for a receptor. Should not be used because of excessive exposure.
Fluoroscopy uses. Used in a variety of procedures. Examples include, first, orthopedic surgery. It observes fractures and falling bones. Second, catheter insertion and direct catheter placement. Angiography, angioplasty. Third, barium X-rays. It observes movement through GI tract. Fourth, blood flow studies. It views blood flow to organs. Other fluoroscopy uses. Injections into the knees through viscosupplementation injections. Then, locating foreign bodies and percutaneous vertebroplasty through treating compressed fractures of the spine. And lastly, injections into joints or spine through image-guided anesthetic injections.
The barium X-rays. Fluoroscopy used alone gives physician opportunity to see movement in the intestines. Barium moves through them during procedure.
Fluoroscopy used alone. It aids physicians in inserting a catheter. Also aids them in detecting blockage in arteries. Its physician can see the flow of blood.
Benefits of fluoroscopy. Because fluoroscopy is an X-ray machine, it has the same risk as other X-ray machines. Two major risks. First, there is a small possibility of developing cancer due to the exposure to the radiation. Second, injuries such as burns caused by the radiation. Benefit: if a patient is in need of a fluoroscopy, the benefit outweighs the minute risk.
Fluoroscopy procedure. Insertion of an IV into patient's hands or arm. Patient move onto an X-ray table. Additional line may be inserted for catheter procedures. X-ray scanner used to create fluoroscopic image of the body. Dye may be injected into the IV at this point. Type of care will be decided on after the procedure has finished.
Procedure is done. A continuous X-ray passes through the body. Then, a beam passes onto a television monitor. Then, body part and motion can be seen in great detail. Parts and functions of a fluoroscopy machine. First, the X-ray tube. It converts electrical energy provided by the generator into an X-ray beam. Bifocus tubes are common. It uses a small focal spot, approximately 0.3 to 0.6 mm. For image recording, using small or the large focal spot, which is 1.0 to 1.2 mm for high tube current. It produces the electrons by heating, and X-ray tube is made up of tungsten. It is positively charged and struck by the accelerated electrons or the emission of X-rays at the focal spot. Then the angle ranges from 7 degrees to 20 degrees.
Intensifier. The image intensifier converts incident X-rays into a magnified visible light image and, in the process, amplifies the image brightness by about 10,000 times for better visibility. It is available with different diameter input windows of 10 to 40 cm. The tube is an evacuated glass envelope and it is vacuum. The glass tube is 2 to 4 mm thick and enclosed in a lead-lined metal container. This lead lining protecting the operators from stray radiation. It does contain 4 basic components. First, input layer or screen. Second, input window. Third, substrate support layer.
The beam filtration. It is common for fluoroscopic imaging systems to be equipped with beam hardening filters between the X-ray tube exit port and the collimator. Added aluminum or copper filtration can reduce skin dust at the patient's entrance surface, while a low KVP produces a spectral shape that is well matched to the barium or iodine KH for high contrast in the anatomy of interest. Insertion of this added filtration in the beam path may be user selectable, providing the operator with the flexibility to switch between low dose and higher dose modes as conditions dictate during a fluoroscopic procedure. The collimation. Shutters that limit the geometric extent of the X-ray field are present in all X-ray equipment. In fluoroscopy, the collimation may be circular or rectangular in shape, matching the shape of the image receptor.
To consider. First, common things to consider. Its area most exposed. Total radiation absorbed. Then, area most exposed. It has absorbed dose. In the general area as well as specific organ. Then, total radiation absorbed. It can result in injuries like burns, etc. Then, caused by prolonged exposure.
At this moment, we would like you to visualize how fluoroscopy machine works through a video presentation.